Hello everybody, welcome back. Our lesson today in algebra, Cartesian product. Before we learning what's the meaning of Cartesian product, we must remember what's the meaning of ordered pairs. The ordered pair open two bracket like this. A is the first projection, B second projection. So this form is what is ordered pair. Either A and B is ordered pair. Each pair represented by one and only one point in coordinates plane. We have y-axis and the x-axis. The order like 2 and 3 represent 2 and 3 in coordinates plane. Move in the right hand 2 units, 1 and 2, up 3, 1, 2, 3, and plot here this point A is the order pair 2 and 3. Okay? Third, if A not equal B, okay, then A and B not equal B and A. What is? The first component A not equal first B, and the second B not equal A. It means we cannot reverse the order pairs. We can learn together the order pair 2 and 3 is equal order pair 3 and 2. No. Why? The first component 2 equal first component 3. So the order pair 2 and 3 not equal 3 and 2. I mean A not equal B and B not equal A. The last remark, or number 4, the order pair A and B not equal set of A and B. With this bracket A and B, it means order, right? You cannot revise A with B, but in the set of A and B, you can write A, comma B equal B, comma A. Okay, so the order and set is not important, but the order in order pairs is very important. Okay, if A and B order pair equal order pair X and Y, so the first component equal first component, second component equal second component. It means A equal X and B equal Y. For example, if X and Y, we need to find X and Y, and the order pair X minus 2, 3 equal 5, Y plus 1. So we take X minus 2 equal 5 and 3 equal Y plus 1. So X minus 2 equal 5 and move 2 in opposite direction by opposite sign, so X equal 2 plus 5 equal 7. And so 3 equal Y plus 1, or Y plus 1 equal what? Equal 3, and solve this 1 بالماينس يبقى so y equals 3 minus 1 equals 2. Now we learn together what's the meaning of Cartesian product. How come? Set A of AB, set X, A and B, and set Y negative 1, 0, 3. So we need to learn together what's the meaning of X product Y, not X multiply. This operation not multiplying but is product. So we learn together what's the meaning of this operation. We take first element in X with first element in Y, inside two bracket make an order pairs, and A with 0 second order, and A with 3 third order, and so on. B with negative 1, B with 0, B and 3. We obtained set of order pairs of the product like this. Look with me. X product Y, A and B, the first set, product negative 1, 0, 3. So we get A with negative 1, A with 0, A with 3, B with negative 1, B with 0, B with 3. This is what is the Cartesian product of X product Y. Now we make another one, Y product X. So we start negative 1 with A and negative 1 with B and so on. We get another product, Y product X. Be concentrating. Look, X product Y not equal Y product X. Why? A product order pair A and negative 1 is equal order pair negative 1 A? No. Why? The first here A, the first negative 1. So the order pair start by the first A, the order pair start by the negative 1. The two orders not equal is what? Not equal. So the product XY not equal product YX. But the number of elements in the first product is what? The number of elements here 1, 2, 3, 4, 5, 6. Okay, and the number of elements in second product is what? Is 6. So note that X product Y not equal Y product X, but the number of elements of X product Y is equal number of elements Y product X. We can make this product by using table. Look with me. X product Y, write in the first column elements of A of X and second elements of Y, and make the product A with negative 1, the first order, A with 0, A with 3, and B with negative 1, and so on. Now we make another table to obtain the product Y and X. Right here in the first column the elements of Y, and second is elements of X, and make the product negative 1A, negative 1B, 0A, 0B, 3A, 3B. We obtained the elements of the second product, and here elements of second of the first product. Okay. Remark. The operations between sets. We have two sets, A and B, and U the universal set. I mean A subset of U and B subset of U. Two sets intersect at these elements of this area, this region. So this area of what? Of the intersections. So A intersects B, 3 and 4. A union all elements inside A or inside B, 1, 2, 3, 4, 7. A difference B, I mean the elements in A only, 1 and A and 2. This is a difference. Here difference B difference A is what is 7. A dash the complement of A. A dash the complement of A. You can move A only. Okay. Try by this. Sorry. Can cancel this area. We get 9 and 7. So A dash the complement the all elements outside A. All elements outside A 9 and 7. B dash all elements outside B is what? 1, 2 and 9. Outside B 1, 2 and 9. Okay? Okay. By using the previous remark, we can solve together with exercise. We have x1 set of element, one element 1 and y2 3 and z2 5 6. Represent these sets x, y, z with Venn diagram. We use Venn diagram. Then find x product y, y product z, x product z, and d2, not y2, not y power 2. This means y product y. The first step, draw Venn diagram and the notes using the above. Z and y has the common element, so the two sets intersection at this element, but x is disjoint with respect to y and z, so x is far from y and z. Now we find x product y. Okay, the 1, 2, 1, 3. Y product z, we have 2, 2, 2, 5, and so on. X product z and y2, y product y, 2, 3, 2, 3, 2 and 2, 2 and 3, 3, 2, 3, 3, like this. Second is very important example, x product y. We make x product y and y product z. We make y product z. We need to find the union. Union, I mean union all elements of the first or together with the second. Order 1, 2, 1, 3, 2, 2, 2, 5, and so on. Third, x product the intersection between what? Between y and z. Y and z has one element in intersection, so the product 1, product 2, the order 1, 2, one element. Now, x product y, intersection x product z, 1, 2, 1, 3, and so on. Fifth, z difference y, the elements in z only, 5 and e and 6. And product x union y, you can try to solve this by yourself. Now we represent the Cartesian product by arrow diagram or Cartesian diagram. For example, x 1, 2, y 3, 4. We find x product y and draw first arrow diagram like this. Here, first column of x and second columns elements of y, and joining between x to y, the arrow from x to y, like 1 with 3, 1 with 4, 1 with 5, 2, 3, 2, 4, 2, 5. The Cartesian product horizontally right elements of x, 1, 2, vertically right elements of y, 3, 4, 5, with order, okay, and denoted the first point 1, 3, 1, 4, 1, 5, 2, 3, 2, 4, 2, 5. The first method is R diagram second Cartesian diagram. Example 5. We have x, 3, 4, 8. Then find x product x. X product x or x2, right? So x from x. يبقى x 3 4 8 3 4 8 3 3 3 4 3 8 4 3 4 4 4 8 8 3 8 4 8 8, like this. We can draw one diagram like this. Okay. Right here, elements of x 3 4 and 8. The first order 3 3. Where is the arrow? From 3 to itself. Circle around itself. And 3 to 4 and 3 to 8. Now 4 to 3, 4 itself, 4 to 8, 8 to 3, 8 to 4, 8 itself. Arrow diagram. Note that number of elements of x is 3 elements, 3 orders, 3 elements, sorry. But number of x product x is what? Is 9. Why 9? 3 times 3. If the number of elements of any set is 4 and complete number of elements of product A, the result will be 16. Why 16? 4 times 4. Okay? And example. Sorry. If elements of product set x and y is 12, right? And number of elements of x is what? Is 4. What's the number of elements of y? The number of elements of y equals what? From definition, number of x product y equal number of x times number of y. So divide 12 by what? By 4. To get number of elements of y is 3. Now we represent infinite set like R, set of real numbers in Cartesian plane. So we have first, second, third quadrants. The first quadrant positive and y positive. Second, x left is negative, y positive. Third, negative together. Fourth, x positive and y negative. This plane is product of R and R. Okay. For example, draw perpendicular square net of Cartesian product R, product R, then tell the quadrant or the axis where each of the following points is located. The first point 3, 3, second 3, negative 2, and so on. Draw the Cartesian plane and plotted A, B, C, D, E, F, 3, 3 here, 3, negative 2, and C, negative 4 and negative 2. It's very easy. D and E locate E locate on y-axis, F locate on x-axis. Note that the interval -2 and 3 closed at -2 closed at 3 represent it by number line, and the -2 and 3 opened at -2 opened as 3 semi-closed -2 and 3. We use this for what? When we draw x equal -2, draw vertical line from what? From -2. And if we draw x equal 3, horizontal line from 3. And this area is x bigger than -2 less than 3 or equal. So x -2 is a line, y3 is a line, x more than less than is region or area, all points between -2 and 3. We use this to now take another example. It's very easy and very important. Set of interval -2 and 3 infinite. Find location which represent x product x. Show which of the following points belongs to the Cartesian product x. Now we represent the first interval x equal -2 vertical line and the y3. This is the interval -2 and 3 vertical interval. The second -2, 3 horizontal interval. This square is a solution of the Cartesian product. Now we plotted A, B, C, D and note together A belongs or not. A1, 2 inside the square here, so A belongs. B3 -1 inside or lies in the vertical line, so belongs to the Cartesian. C outside the square, so doesn't belong to Cartesian. D inside the or lies on the vertical line, so belongs. Now I finished to my session. I thank you for listening to me, and I wish this session is interesting to you, and wait you another session, and goodbye.